Okay, hi everybody. This is Unit 6, Lesson 4, Properties of Logarithms. So we're going to use three properties today. We're going to use the power property, the product property, and the quotient property. And we're going to use those to expand and condense logarithmic expressions. We're either going to make them longer by putting in a lot of logs, or we're going to condense everything down into one log. The first thing I want to introduce is where these properties come from. So the first thing I'm going to do is make a chart. And this chart is going to have all the values for log base 10 of x from x equals 1 to x equals 15. So when we plug this in a calculator is where I'm going to get this. So log of 1 is 0. So just put log 1, get the answer. Log 2 is 0.301. Log 3 is 0.477. Log 4 is 0.602. Log 5 is 0.699. Log 6 is 0.778. Log 7 is 0.845. Log 8 is 0.903. Log 9 is 0.954. Log 10 is 1. Log 11 is 1.0141. Log 12 is 1.079. Log 13 is 1.114. Log 14 is 1.146. And log 15 is 1.176. Again, all of those just came from a calculator. I just plugged them in for log base 10. That's why I use log base 10, so that these values will be really easy to find. So now I'm going to add some things up. I'm going to add up log of 3 plus log of 5. So log of 3 is 0.477, log of 5 is 0.699. When I add those together, I get 1.176, which you'll notice is on the chart, it's at log 15. Okay. Now I'm going to add log 1 plus log 7. Now log 1 is 0, log 7 is 0.845, so when I add those, I get 0.845, which again is on the chart already, it's log 7. Log 2 plus log 4. Log 2 is 0.301, log 4 is 0.602. I add those together, I get 0.903, which is on the chart at log 8. Okay, and then one more, log 6 and log 2. Log 6 is 0.778, log 2 is 0.301. I add those together, I get 1.079, which is on the chart at log 12. Hopefully by now you can see the pattern, so I can make a more general statement. Log m plus log n. So, look at number 1. Log 3 plus log 5 gives me log 15. And you'll notice that 15 is 3 times 5. Log 1 plus log 7 gives me log 7, and 1 times 7 equals 7. Log 2 plus log 4 gives me log 8, and 2 times 4 is 8. And then log 6 plus log 2 gives me log 12, and 6 times 2 is 12. So if I have log m plus log n, then the answer to that is going to be log of m times n. And that's called the product property, because we're changing two different logs that are added together, and what I do is I multiply together their arguments to combine them into one log. And just a note that works for all bases. So more generally, I would say that log base b of m plus log base b of n equals log base b of m times n. Now this has to be the same base. If I have different bases, none of these properties apply. So we won't see many problems with that, because that's not very interesting. So what if it was subtraction? What if it was log base b of m minus log base b of n? Well, in that case, much like addition, subtraction is the opposite of addition, so you imagine that I would do the opposite of multiplication. So instead of multiplication, I use division, because that's its opposite. So that means log base b of m minus log base b of n equals log base b of m divided by n. And that is called the quotient property. Okay, the last one comes from this. What if it was, instead of log base b of m plus log base b of n, it was log base b of m plus log base b of m? Well, that's going to be log base b of m times m. Now I'm going to rewrite both sides of this equal sign. On the left, I have the same thing added twice, and that's what we call multiplication. Repeated addition is multiplication. So that's 2 times log base b of m. Just like if I had z plus d, that would be 2z. And on the right, I have log base b of m times m. And m times m, that's called a power. That's m squared. So you can see if I have a number multiplied times a log, I can change that, and change that to a power associated with the argument. And that works not just for 2, but for all variables. So if I have x times log base b of m, then that x out in front of a log is going to move up to an exponent next to the m. So that's log base b of m to the x power. And that's called the power property. So just to review, here are the three properties. Log base b of m times n is equivalent to log base b of m plus log base b of n. That's called the product property. Log base b of m divided by n, that's the same as log base b of m minus log base b of n. That's called the quotient property. And then we have log base b of m to the x, and that's equivalent to x times log base b of m. That's called the power property. Here's an example of the kind of problem we're going to use to solve it, to use these properties for. So the goal here is to condense these separate logs into a single log without any multipliers in front of it. So let's start, we always start with, when we're doing this process, we start with the power property, and then we use the multiplication, the product and quotient properties, because just like the order of operations, exponents come before multiplication and division. So if you look at this, the place where I can use the power property is where I have the number out in front of the log, the multiplied time, the coefficient in front of the log. That's at 3. So I have 3 log base 2 of x, and I can rewrite that as log base 2 of x to the third power. Remember that 3 out in front becomes the power. At this point, I can use the product property, which is addition. It's not the quotient property because it's not subtraction. So the argument of the first one is x to the third. The argument of the second one is y. I can condense those together, and I have log base 2 of x to the third times y, and I'm finished. So here's some examples of problems. If you did these, I'll give you the answers to see if you did them right. Okay, we're going to start with the first one. That's log of 20 minus log 4. You're going to use quotient property, and you just come up with log 5. The second one, you're going to have log base 4 of 3 to the 4th minus log base 4 of 9, and 3 to the 4th has a value. It's 81. So we end up with 81 divided by 9, which is log base 4 of 9. Finally, we're going to use power property to get log base 4 of 2 to the 3rd. 2 to the 3rd is, of course, 8. So that's log base 4 of 8 plus log base 4 of 3. That's going to give us the 8 times 3, which is 24. So that's going to be log base 4 of 24 minus log base 4 of 6. Now we have minus, so we use the quotient property. 24 divided by 6 is 4. So I'm going to end up with log base 4 of 4. And when I evaluate log base 4 of 4, it's 1. Whenever the base matches the argument, the answer is 1. The other thing we're going to do is expand logarithms. So if I have a logarithm like this, log of 3 times r to the 4th power, I'm going to expand it so that everything is in its own log. So I'm going to use this and do the opposite of what I did before. And I'm going to use essentially doing it backwards. So if in order to condense them, I use the power property first, when I'm working backwards, that means I have to use the power property last. So that's exactly what I'm going to do. The power property comes last. So I look for products property, and I look for quotient property. Now this one doesn't have any division, so I won't be using the quotient property, but it does have multiplication, which means I'll use the power property. So I have 3 times r to the 4th, and I can separate those into 2 logs that are separated by addition. So I have log of 3 plus log r to the 4th. At this point, I can use the power property and move the 4 that's in with the r out to the front of that log, and I get log of 3 plus 4 log r. A few more examples. Now, number 1, people get a little freaked out by because it's ln instead of a log, but you have to remember, you treat it just like as if it was log base e, which means you don't really have to worry about what the log base is, you just keep writing the same thing over and over again. So since this is x divided by y, the quotient property says division gets expanded into subtraction, so that's natural log of x minus natural log y. Number 2, we use product property to get 3 plus log base 2 of b, and that's because we have log base 2 8 plus log base 2b, and log base 2 of 8, if you evaluate it, that's 3 to what power gives me 8, 2 to what power gives me 8, and that value is 3. Now number 3, that's going to be 5 plus 4 log base 7 of b. That's because when you do log base 7 of 7 to the 5th power plus log base 7 of b to the 4th power, and use power property, you get 5 times log base 7 of 7. But log base 7 of 7, the base matches the argument, so the answer is 1. So that's 5 times 1 is 5. And then the 4 from the exponent 4 moves out from the b out to the front of a log. This is the other formula we're going to work with, and we're actually not going to do any problems with this on your homework, but it's a really handy formula to know. This is called the change of base formula. And what this allows you to do is calculate the value of a log of any base, in this case base b, by using a different base. I would suggest using base 10 or base e because those are the bases that you can use in your calculator. So what we can do is use log base 10 to calculate a log base b. Let me show you how it works. Log base 8 of 47, if I use log base 10 and use the change of base formula, that becomes log of 47 divided by log of 8, which is equal to 1.852. Similarly, I could use natural log and do the same thing. Natural log of 47 divided by natural log 8, and that's going to be 1.852. So I can evaluate logs without having to directly use any base. I can just use base 10 or base e, i.e. natural log, all the time. Log of 70 divided by log 6. Number 2, I would do log 27 divided by log 2. Number 3, I would do log 500 divided by log 14. And number 4, I would do log 3136 divided by log 56. And all those are going to give me the answers for these without having to directly plug in the base into the calculator. So here's your homework that I need you to work on. It's page 110, 12 to 46 in threes. Be careful that you don't start on number 3, that people tend to start at the beginning of the page, and this homework does not. Okay, so I'll see you next class. Good luck.